Hello, in this video we will look at how we can use the Ti-83 or Ti-84 inverse norm function to find the z-scores for given areas under the normal curve. So the questions basically we're going to ask is, what if the problem gives us the area for a specific region? Can we then find the z-score that would define that specific region? So we have example 6.6. It says find the z-score for the indicated shaded area of the probability below. So we're given in part A that the area to the left of some z-score is 0.1466. We know it's to the left because it's shaded to the left. One thing that we can notice here is that the z-score is about -1. It's not exactly -1, but it's about -1. So we'll make sure that our z-score is about -1 when we do these. So if we are given an area, and asked to find a score, in this case a z-score, we're going to use the inverse norm function in the calculator. To get to that function, we're going to use second vars. In this case, I'm going to use number 3. Now, all my calculator is going to ask me is, what is the area? I'll show those. I'll show the steps for using the Ti-83 or the older display Ti-84 in a minute. But basically, we are going to think in whenever we're using the inverse norm, we're going to think about using the area to the left for all of these. So for part A, pretty straightforward. We already have the area to the left. For part B, we're going to need to do a little bit of work to make sure that we're finding the area to the left, because that is the only area that our calculator is able to find. Some of you with even newer calculators than mine might have a left, right, center option, in which case you can choose left, right, or center. And I'll explain those when we move on from here. But my really frustrating or boring way of doing this is to think of Beyonce. Because every time we use inverse norm, we're always using the area to the left, unless you have a fancier new calculator. Uses area to the left. All right, so that was a long introduction to something that's going to be pretty straightforward. We're just going to type in 0.1466 for the area, mean of 0, standard deviation of 1, and we'll get our z-score of -1.05. For those of you that are using the older display calculator, just slide this over a little bit. The area is always area to the left. Area to the left. The next thing we're going to be looking at is the mean, and then the standard deviation, all of which have 0 and 1. Sorry, all of which have commas between them, is what I meant to say. All right, so now let's look at example 2, or example B rather. Example B has an area of 0.20 to the right. It's shaded to the right, so therefore we're looking for the value, the z-score, that has an area of 0.20 to the right. You'll notice that the z-score is probably about 0.9. So that should be close to our answer. Now, using my calculator, I need to type in the area to the left. Again, always thinking of Beyonce. Everything is to the left. Haha. When we do the second vars, number 3, inverse norm, because again, we're given the area, we're trying to find the z-score. I'm going to do this in 2 different ways. The first way is, since I know the area to the right is 0.20, I can actually just type in 1 minus 0.2 as my area. And I'll find that my z-score is 0.84. Again, it was about 0.9 was our estimate. We're good. We are right around where our estimate is. Now, I could have also just done 1 minus 0.2 on paper and written this as 0.8. So if the area to the right is 0.2, the area to the left is 0.8. So the reddish area is 0.8. I could have just typed that in as well. Again, those of you with the older display calculator, no big deal. We just need to type in the area first, comma, the comma is just above the 7 button, 0, comma, 1, and then close parentheses, enter. All right, I have 2 more pictures here. For part C, we're looking for a z-score approximately the same as what we had before, maybe about 0.8-ish, 0.8-ish for my z-score is my approximation. Again, whenever I'm using the inverse norm function, I'm always trying to find the area to the left, which we are already given is 0.7673. So I can just hit second enter. I'll show how to type all of this in as if I were using an older calculator, which is no big deal. I'm just going to delete all this. The area to the left is 0.7673, comma, 0, comma, 1, close parentheses, enter. And I'll get my z-score is about 0.73, which was close to our 0.8-ish estimation from earlier. All right, part D is going to be very challenging. So I went through the first 3 quickly. Let's look at part D now. So for part D, we see that the z-scores, or the shaded area rather, are between 2 z-scores. We have what looks like a z-score of 0 as our lower value, and a z-score of maybe about 0.4-ish. Z is about 0.4-ish is my estimation. We don't need to do these estimates on a regular basis, but I'm just doing this for the video to make sure that we're fully understanding what it is that we're trying to calculate and what it is that we're trying to find. All right, so because of that, we have multiple different regions. Let's go dark blue. We have the region to the left of 0, which, if you remember from a previous video, the area to the left of 0 should be 0.5000, or about half the graph is going to be to the left of 0. We're given that the shaded region is about 0.1808, and we can find the area to the right went and disappeared on me. The area to the right is going to be whatever the remainder is. I can find that in 2 different ways. The first of which is I can separate the graph into 2 different regions, 0.5 to the left and 0.5 to the right. Well, I know that if my area in the purple shaded region is 0.1808, if I do 0.5 minus 0.1808, I will find the red shaded region. 0.5 minus 0.1808 will be 0.3192 is the red shaded region to the right. I also could have done 0.5 plus 0.1808, which would be all of this, oh, I guess we could just highlight it, which would be all of this region, the purple shaded region and the left half of the graph. We would see that that is 0.6808, and if we do 1 minus 0.6808, or the complement of that, we'd still get 0.3192. So 2 different ways of getting the same results. Whoopsies, what just happened there? Hit the wrong button. All right, so now we need to find the 2 z-scores that this region is between. The z-score to the left is 0, and the z-score to the right, using my calculator, I would need to do second vars, number 3. The area to the, or the z-score to the right, which we estimated to be about 0.4-ish, will be all of the area to the left of it. Let me go with a nice new color here. Let's go with orange. We haven't used orange today. So the area of the orange shaded region will be 0.6808 because we will add the 0.5 plus the 0.1808, giving us a total area of 0.6808. Oops. Again, when we're using inverse norm, we're just using the area to the left. If you have one of those fancy new calculators, you could have just used 0.3192 and chosen shade to the right, and you get the same thing of about 0.47, which is close to our approximation from earlier. All right, I have two more pictures here, and then we have a few more examples after that, where we'll have to draw our own pictures. So in this first one, we are given that the area to the right is 0.025. So again, in my calculator, let me go through this a little bit faster. I would need to find the green shaded region. To find the green shaded region, I would do 1 minus 0.025. 1 minus 0.025 would be 0.975. So the green shaded region is going to be 0.975. So second bars, number 3, 0.975, mean of 0, standard deviation of 1, will give us a z-score of, oops, forgot to hit enter a second time, 1.96. All right, and then graph F. Graph F is going to be challenging. Let's go with plum. So we have 3 different regions of this graph. We have the purple shaded region, which is 0.7887. We have the plum shaded region, and we will have the lime green shaded region. So in order to work with this, again in my calculator at least, I need to choose the left area. If you have a fancy new calculator, you could choose the center area because this is assumed to be symmetric. We can tell because if we look at the z-scores, it should be about the same z-score for both of them. So therefore, we could use the center option if we have the center option, and you could just type in 0.7887 and find the z-scores that cut off the center 0.7887 of the graph. I don't have that option, so I need to do this in multiple different regions. So I know that this area here, we can call this area L, and I know that this area here, we can call this area A, or area R rather. How's that? Left and right. If I were to add these two up, this would be the complement of 0.7887. So if I use this color here, 0.7887, if I were to add all of these up, I would get 1. The plum area plus the purple area plus the green area will all equal 1. So if I were to subtract 0.7887 from both sides, doing this a little bit algebraically, 0.7887, I would find that the tails of the graph would have a total area of 0.2113. So area L plus area R are equal to 0.2113. Since these two tails are assumed to be the same, we can divide these by 2, and we'll see that the left shaded area is going to be 0.10565, and the right shaded area will also be 0.10565. Now I can prove that to you real quickly. Plus 0.10565, enter, plus 0.7887, enter. We'll get that the total area is 1. Perfect. So, where are we at so far? Well, we've been talking a lot about the areas of these graphs. We haven't really talked about how to calculate them yet. Well, again, in my calculator, I need to find the area to the left and type them in. So I can find the lower z-score by typing in 0.10565 for my lower value. Sorry, the area to the left of my lower value. And I'll get that the z-score is negative 1.25. Since this is symmetric, I know that the z-score, my apologies, of the upper value will also be 1.25. It'll just be positive. But just to make sure, second vars, number 3, we could also do 0.10565 plus 0.7887 to find the total area of the highlighted region, which is everything to the left of this highlighted region. So I can do all of that right in the inverse norm window. And I'll get that the z-score to the right is also 1.25. All right, so there's how we can find the z-scores given areas of pictures. I know this video is getting long. I do want to show just a few more quick examples of how to find the z-scores given areas. Now these do not have pictures, so I like to always sketch a picture for these. I'm going to go through these really quickly. Basically, each of these, if we're talking about percents to the left, we're really just talking about percentile ranks. So if we wanted to find the z-score that cuts off the lowest 20% of the area, we're really just looking for the 20th percentile. Well, that would just be the area to the left of 0.2. So second vars, number 3, our area to the left is just 0.2. And we'll get that the z-score is negative 0.84. That's our answer. For part B, it's asking for the highest 10% of the area. If we're looking for the highest 10% of the area, we're really looking for the 90th percentile. So again, I'm just going to go through this as quickly as possible. We're just going to change the area to 0.9. If the area to the right is 10%, the area to the left is 90%. Making that into a decimal, we'll get 0.9. So I'm just going to type in 0.9 for my area, and we'll get that the z-score is equal to 1.28. Now C and D, again, are dealing with the middle. I'm going to do these quickly. We're given that the middle 90%, middle 90%. If we're talking about the tails then, that means that the green regions, when we add it together, will both be 10%. So each of them will be 5%. So in my calculator, I can find the lower value by using an area of 0.05 And I can find the upper value by using a total area of 0.95. Because I would be adding the 5% and the 90%. So I'll do that really quickly. 0.05. We'll get that the lower value is negative 1.645. And then if I hit second, number 3.95. We'll get that the upper value is 1.645. Again, if you have one of those nice new calculators, you could just use 90% or 0.9 and then choose center. And that'll give you the two different regions, two different z-scores. For the last one, if we're looking for the middle 50%, 50% of the graph. Then we know that the two tails are both 25%. So really we're looking for the first quartile or the 25th percentile and the third quartile or the 75th percentile. So we can hit second vars, number 3, change this to 0.25, and we'll find that the z-score is negative 0.67. And then we can hit second vars, number 3, change this to 0.75, and we'll get that it is positive 0.67, because again, the graphs are symmetric. All right, I hope that this video was helpful. Again, I know it's a longer video, I apologize for that, but I wanted to go into some detail about the first couple of examples. I hope you enjoyed it. Have a great day.